Hello, everyone. Welcome to the Tom's Hardware Podcast for July 5th. We're in July already. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, and I am joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, Debra Ansell from GeekMomProjects, a true maker celebrity. We're so excited to have you on the show. Really big fans. And what can you tell folks who aren't familiar with your website and your Twitter about yourself and how you got started in making?
Well, thank you. First of all, celebrity is weird, but it's a nice feeling to be known and to be kind of recognized in an area where the recognition is for what you do and whether people like it and want to do it. So I'll take that in that sense. Thank you. I got started making. It's funny because I didn't know anything about hardware really. I had a science background and had learned. I'd studied physics, learned, the theory of circuits, but hadn't really started in hardware till my middle son was about 8 years old, which is almost 12 years ago now. And he started wanting to do Lego robotics. And by getting involved in coaching his Lego robotics team, I started to learn about Arduino and all the fun, cool things you could do with hardware, and started with Arduino LilyPad. And obviously the love of LilyPad and LED wearables, kind of led me down this path that I've experimented with a lot of different media, though almost always with LEDs, not always, but almost always with LEDs. And the ability to actually make things has been just overwhelmingly a positive kind of self-reinforcing driving force in my life since then, because I love it. And it's just become an enormous creative outlet for me. I've always felt creative, but I was never artistic. And when I could use CAD and I could design and I could code the things I wanted to have happen and then fix bugs later on, it was really a revelation and led to kind of a lot of what you'll see. I'll just, going on in my office over the years.
Oh, that's nice.
That's a lot of LEDs. I love that.
Yes, it is. And it's all good.
Come decorate our sets for us.
Would be my pleasure. My absolute pleasure.
That is fantastic. So do you still work on these with your kids?
No, my kids outgrew me a little while ago. My the son who got me coaching his Lego robotics team is now studying computer engineering and is actually kind of high up in the hierarchy of his own combat robotics team in college now. So it's fantastic. So no, there's not much I can teach him at this point, or at least that he thinks I can teach him.
He's gone beyond the Arduino, huh?
Yes, he has gone beyond the Arduino, and I have offered, you need LEDs for your robot, but that has not. No, I think he's more concerned about armor and weaponry than LEDs, but to each their own.
That's cool.
Yes.
All the LEDs. DIY.
All the LEDs. That's right. That's a great motto.
That is great. So do you use Raspberry Pi a lot, or do you just how do you decide what kind of controller board you use for your different projects?
It really depends a lot on the size of the project and the nature of it. A number of projects in my office right now are running off of Ben Henke's Pixel Blade, which his website is Electromage, and I like that for 2D projects because when mapping, it makes mapping to different shapes super easy. So, for example, that LED matrix back there is running patterns, as are these two pillows running off a single pixel blaze, and actually that parabolic string hyperboloid as well. It makes it very easy to take the same patterns and reuse them with different mapping and have them still look really good no matter the sequence. So it's mostly because it's easy. So I almost always prototype with that, or Circuit Python boards as well. Here, this one's fun. This is a little tiny. This is a actually, I'm not sure if this is running CircuitPython or Arduino, to be honest, but this is a Fibonacci board that I turned into a bracelet. Isn't that cool? Yeah, I was playing with we'll talk about this, I think, in a little bit too. I've been playing with battery holders for a while and trying to work them into wearables. But you were asking what board I choose, and I tend to try, I love the Cutie Pie boards. You can see there's a little, I don't know if it's going to show very well there. Yeah. It's cute. It fits in small spaces. And for wearables, you know, especially the smaller, more inconspicuous wearables, you want to be able to hide the electronics. So Cutie Pie works very well. So there's a Cutie Pie controlling this Fibonacci board, which I've turned into a bracelet. And the hardest part now, because the boards have gotten so small, is finding places to hide the batteries. And that's, there's a limit to the energy density. And of course, more LEDs is generally better, but it also draws more power. So that's the perpetual struggle.
No question. Always the issue. So can you tell us about some of the cool things that we see behind you?
Sure. There's a lot of them are from different phases in kind of my making history. So it's a little bit of a archaeological LED museum. I don't know if that's quite the right word. So just like kind of the general overall theme, you'll notice is while I love LEDs, I want to see them in different configurations and different shapes. I don't want them to look like point lights, and just like a single blinking bright light. I want ideally to paint with them or fill space with them. And that was kind of the genesis of what you can see. Hold on, I'm directionally challenged here, but if you can see these edge-lit shapes right here, I gave a talk on these for Crash Space. They had a session a couple of years ago, and those were a technique I did for a while of embedding LED strips actually inside thicker acrylic so that the LEDs could illuminate laser cut pieces and kind of fill it's a little bit almost like paint by numbers. It automatically fills the space that you laser cut. And that was really fun. And that was that 3D orb was an attempt to do the same. It was an experiment going to 3D.
So those are made with strips, not... Oh, sorry, Liz.
Sorry, I'm just saying it looks like a warp core.
Yeah, it does look like something out of Star Trek.
Yeah, that's good. I'll take that. But yes, those are LED strips, narrow LED strips placed sideways. I called it inner glow. It was a technique I used. I don't have a rainbow on me, but I used it for a lot of different projects and really kind of explored that as much as I could. I may go back to it, but I love the way light diffuses in acrylic, and just the whole overall appearance and the ability to generate interesting, different shapes out of light.
Right. Have you ever constructed using individual LEDs and put them into place rather than starting with a strip and then solder it all together?
In a sense, with circuit boards, I have certainly. But that when you're doing the CAD for the board, you're figuring out where you want each LED to go. So I've started with that, right, where you're not constrained to a certain LED spacing. Although, I'm a little bit lazy, so I'd like the convenience.
Also, work smart, not hard.
Well, yes, and to be fair, when you're doing things like I am, where you're bending and moving things around, it's nice to have like sturdy wiring between them. So I'd rather. Definitely. I have tried to, and I think the last time I did that, I did an LED hat. Here, if you'll humor me 1 second, let me grab this. Where I took. This is a fiber optic. I don't know if I have, I don't think I have it powered up. I'll just show you how it works. But I did post to my Twitter if anybody wants to see it. But it has fiber optics here, and I'm sorry, it's not powered, but it's powered by LEDs that are tucked in the brim. But they could only shine in a single color. So I replaced them with programmable LEDs that I did wire individually to various places. And I'm going to have to post a link to my Twitter to show what it looks like afterwards. But yeah, so I will do it. I'm just very cautious after such a long time working with wearables of the difficulty of keeping wiring intact in something you're going to wear in particular. And I like the challenge of finding ways to take LEDs with a fixed spacing, but on a string that may bend, and kind of make them look interesting, which is kind of what I did with this string art, and this, I always forget if it's a hyperbolic, I think it's a hyperbolic paraboloid, not a parabolic hyperboloid, but you can construct, you basically, everything here is straight lines, but of course it constructs a 3D shape, and you have to do, the trick is to do a little bit of math beforehand with all the dimensions so that the regularly spaced LEDs fall in like uniform positions along the straight lines that you're constructing your 3D shape out of. So I like that challenge too. So in a way, I view kind of having the constraint of your pre-configured LED string as a challenge to see what I can do with it. But it does, constrain your projects a bit because you can't put the LEDs just anywhere. Absolutely.
So how do you get the effect that it looks like there's lights underneath the pillow? Are there actually underneath the cloth?
Yes, I'm a big fan of finding interesting ways to diffuse LEDs. Not only are they underneath, I'm going to be writing this project up for Make Magazine. So this was my first stab at it. I think I've figured out a better way to do it. I'm looking for the zipper right here. See if I can do it without, taking it too much apart. But what I did, so it's a regular standard pillowcase. Underneath is a layer of quilting batting. And underneath that, I don't know if you can see, I've literally sewn an LED string into.
Yeah, we can see.
Nice.
It's basically, these are Christmas lights, right? But it's they're very flexible, and I think they're nice and safe. They're resin encoded. I feel pretty comfortable using these in fabric. So it's just literally sewing it down to the pillow. I think the next iteration, I don't know why this didn't occur to me in the first place, but I won't sew it directly to the pillow. I'm going to make a pillowcase cover especially to hold these that can just slip on or off. So you could, swap in and out the pillows, which makes more sense. But this still worked out quite nicely. And it was a lot of fun to do.
Where's the battery?
Oh, this is plugged into the wall. It's, it's 200 LEDs. So it can run off a battery, but it's just easier to plug it into wall power. It's furniture, or it's home decor. You can keep this wired without too much difficulty.
Cool. Yeah.
Yeah. Thanks.
That's that is great. So, what advice do you have for folks who want to get who want projects they can work on with their children?
First of all, find what your kids like, first of all, because not all kids like all things. My kids were very enthused about things they could make a mess out of. Electronics are a little tricky because they only work if you do it correctly. So you have to, depending on your kids, some kids are in there just wanting to make messes, or some kids are in there just wanting to, just wanting to do what they want to do, not doing what the instructions say. So that can be tricky. So you have to kind of set expectations for we're going to have a great result, but we're going to have to follow the instructions. And then find age-appropriate projects, and ideally ones they can customize a bit. So I have a number on my blog. Many of them require access to a laser cutter to make the parts and things like that, but you can order laser cut parts online. Adafruit has wonderful projects at all levels, and LEDs, everybody loves LEDs. Find something to make something light up, because kids will generally love that. There's simple things like copper tape circuits. I'm also a big fan of microbit because there's an infinite number of projects you can do with microbit and just a little bit of code. And kids are always amazed at how easy it is to build out projects like that. My advice is just probably helps to agree on a project together first, and make sure you set expectations appropriately that this will work if we follow the directions this way. And things like sewable circuits, there is like latitude for decoration and fun. And it's too bad I don't have one here, but I like to make projects where I have on my website, there's an infinity mirror kind of bug creature that is actually very kid friendly, that you can make it, but then you can add the pipe cleaners and customize it yourself to look however you want. So, there are great resources out there. Adafruit, Microbit, a lot of a lot of small makers also have very child-friendly projects at will. I think Brown Dog Gadgets is another one. So you just look and find something you want to work on together.
Yeah, no doubt. My 10-year-old and I have been doing projects together for like 5 years now. Although lately, all he wants to do is something having to do with Minecraft. That's all. That's all he cares about in life right now.
Yeah,
But
you can get, but you can integrate, right? The great thing is you can integrate, I think, Minecraft with MakeCode. There's a whole MakeCode Minecraft module, and
yeah,
coding things like that.
yeah, he likes to program modules for it. He wants to like learn Java so we can do better modules. I prefer to do physical stuff with him, like build robots, whatever. So we've been through a lot of robot kits, which have been kind of cool. I think wearable stuff he also would appreciate because it does something. I think to your point, kids need things that they see the result.
Yes. That's physical computing. Making things happen in the real world is such a tangible, wonderful way to start to encourage kids. I checked to make sure this is working. Just speaking of wearables and education, this is I have a series of LED bags and backpacks powered by Microbit. This is cool, and this came out of a desire to. It's powered by Microbit inside, so there's a number of different varieties of bag and backpack. If you open up the compartment and pull out the circuit board, you can see it's a just simple LED circuit board powered by Microbit and a little battery, and it actually snaps right into the container here. And I was inspired to build this. And by the way, this is a product that is now being sold. I'm collaborating with Alpenglow Industries to sell these bags.
Wow.
But I made it a while ago, and I was inspired to do it because after working with kids for a while, I love coding and physical computing. But I found girls in particular are not always inspired by robotics, but there's so much you can do. And this is such a fun, wearables, codable wearables are such a hands-on project you can show off, collaborate, especially it's something you can do with your friends. Microbit's wonderful because it has built-in Bluetooth that makes it in a way that's super easy to use. So, you can code a bag with your friends and take it out and have them interact. If your friend comes close, change colors, all these wonderful things. And that did grow out of a desire to see kind of hands-on experimentation and kid-friendly making happen in maybe non-traditional kind of settings or non-traditional kind of areas like wearables.
Cool. So I understand that you're working on a project in collaboration with two other makers. Can you tell us about that?
Absolutely. I'm wearing it right now and I love it. This is, I've been working on wearables for a long time, and my goal is always to, have a wearable that doesn't look like a wearable, that's cool, that's dynamic, that's interactive. And I'm really excited about this because I think it took 3 of us coming together to really make it work in a way. I couldn't have done this myself in the slightest, but it's a pendant. It took us a while. We've come up with a name called Lex Lavalier. My collaborators are Jason Kuhn of Evil Genius Labs, and he makes these wonderful, hi Jason! He makes these wonderful Fibonacci boards. There's one running back here. And it's hard to see, but it's LEDs arranged in a spiral shape that are the Fibonacci spiral, which is found in nature, and it's very aesthetically appealing. It's the most space efficient way to arrange to space dots in a plane, and it's just very visually appealing and makes for some really nice, easy to control, easily beautiful patterns without too much coding work. And so that's the board, and that Jason's brought that to the project. The second collaborator is Ben Henke, who makes the Pixel Blaze controller, which I think I mentioned earlier, is controlling these pillows and that wonderful LED matrix and that hyperbolic paraboloid, and probably a few other things in here I'm forgetting, as well as this pendant. And his controller is amazing. Hi, Ben. His website is electromage.com, and it's codable. You can go in. They're wonderful. It's easy to set up. Very it's almost turnkey. You have to have a little bit of comfort in wiring something and screwing in the wires to the controller, but it really works right off the bat, and it has a very nice interface that lets you take standard patterns and map them to any pixel configuration with a very minimal amount of work, and super, super easy with a wonderful web interface. And my contribution here, can I switch to overhead for this?
Yeah,
great. So I'll show you over here. So my contribution to this is actually the smallest part, but it has been the result of a lot of work, is this behind the neck battery holder, because as I said before, finding a space to put the power is always a challenge, because it's bulky and you want your wearables to look pretty and sleek and small. So this is I'll show you before it lights up. This is the pendant right here. It's got a LED acrylic on top. Under this cover, there's a small pixel based controller, I guess, which looks, if this is what it looks like uncovered on the back of a different pendant right there. And the if you can see from the side, the Fibonacci board is right there. And my contribution is a way to complete the circuit by wearing the battery behind your neck. And this is a lithium ion battery. You just slide it right in. And there's a magnetic clasp that clicks into place very easily. And after just a moment, there you go, it lights up and cycle through some beautiful patterns that you can control and code yourself, or use some pre-made patterns. And it's fun. There's a little button on the back. You can click it and switch to different really pretty patterns, and you can control it dynamically through a web interface.
Oh, cool.
And
That's
it's
lovely.
really, really wonderful. Yeah, thank you. And it's been a great experience working with them. They're so nice, and I've loved their work, for so long. And it's neat that, to be able to combine elements that we've all worked very hard on. Even though this looks pretty simple, I can show you how long I've been trying to come up with a behind the neck battery holder that I really liked, because I've got some earlier prototypes. But yeah, it's really, really nice that I think it's kind of all of our best work coming together in a really beautiful product. So hopefully we'll see. We're still working on getting it out, and we're still working on coordinating all the details, because it's, when you add more people to a project, it doesn't, it can make things more complex. But in terms of getting the parts to each other and figuring out all the details, and it's more a case, because they're both so nice, of like, I want to make sure you're happy, and they're like, no, but we want to make sure you're happy than anything else. So it's fun. It'd probably be easier if somebody in the group wasn't so nice and would just kind of take charge and say, this is the way we're doing it. But it's been a great experience.
How much does that battery, does it cause too much pull or anything, or like weight wise?
No, it's not. I'm wearing it right now. No, that was a balance though, because there are, so many different sizes of lithium ion batteries. I definitely tested a lot of them, and it's the size of a standard AA lithium ion. It's 14500. I tested a bunch, because you can get them in all sorts of different sizes, and this was the best compromise between not too much weight. The ubiquitous 18650 that you find in like vaping and everywhere else is too much. Yeah, and we'll pull it down. I find this is pretty comfy. If it helps if you're wearing a collar. It may, if you were like limboing or something, it probably would slip back, but it's not. Generally, friction, like the friction of the back of your neck, will hold it in place just fine. I find it very comfortable.
Are you concerned at all about wearing a lithium ion battery? I know people get concerned about safety.
Yes, actually, I know. Like, I went to great lengths when I made my purse to this is powered off of alkaline batteries, but that's just bulky and impractical. So that was why I really liked the magnetic clasp, because it comes right off. You just, if you were to pull it, poof, it literally unclaps. It's not stuck. You can pull it right off with doing that. And it's a cylindrical battery. It's not it won't go puffy on you. It's in a hard case. And there's a little bit of protection, on the back of your neck, because it's in an enclosed container there. But yeah, we have done a lot of testing, and we're, making great pains to keep power draw low and give everybody warnings. But yeah, I've probably spent more time wearing lithium-ion batteries than anybody I know. And I think with reasonable safety precautions, no. I worry about people not taking safety precautions. Yeah. So the first kind of versions I think we're talking about releasing is a kit where you would solder it yourself. So generally you'd have a little bit of knowledge to put it together, a little bit of understanding of electronics to put it together yourself before wearing it.
Right. But really, that's so cool because then you can really stand out. I mean,
that's exactly, you can customize it, right? It's exactly what you want, the colors you want, the patterns you want, everything, and that's what makes, LED or any kind of wearables, that electronic wearables, so much fun. It's yours to customize, create, and and decorate and personalize. Yeah, that's an aspect I love. It's super easy to go through the playlist of patterns and just select the ones you want. And I'm going to hopefully give kind of a seminar on how to use the coder. So you could go in and you could say, oh, this is really nice. I just wish it were red instead of blue, and just go into the code and do it super easily. I mean, this is customizable to the extreme, really. So it's a nice feeling.
Great. So speaking of projects that we're working on, Les, you have something you've been working on.
I have indeed. This is it was a shortly conceived concept that I had about 6 hours before I should have gone to bed the night before going to a conference last Friday. So, well laid plans. So Tufty 2040, the board that came out last week. So it's a TFT screen and a
very wearable.
Yeah,
very wearable.
I'm waiting for a good TFT wearable. Yeah, that's.
Well, wait no more, because Tufty 2040 is here. So there he is, inside my case. Now, this is a 3D printed case that I designed. Now, the problem I had was on Friday night, I thought, I want to take this badge to the conference because I'm going to be masked up, so no one's going to see my face, which is a blessing, really. But they need to know who I am. So, a badge. I didn't want to take a bare lipo, because as we know, and Debra's mentioned as well, bare lipos are a little bit dangerous here and there. Here's a bare lipo that could cause a dangerous juice box situation. So, I wanted a case. So I 3D printed one. So I went and looked around. Is there a 3D print for this? No. I asked around on Twitter. Is there one? No. So I made my own. So I went to Pimoroni's website, and they had a schematic on the website which had all the layout details, so all the measurements, that sort of thing. So I did a 1-to-1 ratio, copy of that. It as an SVG. Drew around all the bits I needed to do. Copy, pasted it, reduced the size, make it so it was the right size for printing. And then I chucked it into Tinkercad. So this is live Tinkercad. You can see it moving around. If you get motion sickness, look away now. But you can see the 3 segments to it. So there's the top bit just here. And that's where the hanger is to hold on to the lanyard. There's the back. Now these 2 bits here are the most boring bits. They're just flat pieces with a bit of cutout here and there, just to make sure that they fit around. The tricky one was the center section, this middle bit. Because as you can see, there's a few cutouts. So just here, and there, and here. So that's a USB-C port. I'll just move my camera to center. There you go. So that's where the USB-C port is. Down here are a load of components on the board. And over here is where the STEMMA QT connection is. So I had to put some cutouts in there. And I also did a few more for the bottom, just for good measure. And printed it out over a few iterations. And there are many iterations there. I think up to version 5 so far. So I sliced it in Prusa. I hope I'm saying that right. I always get it wrong. And it was a considerable amount of time to print it. It's about 5 hours, I do believe.
Shoo.
And this is all 3D printed on an Ender 2 Pro, which is a machine that we've reviewed. It's £160, and I think it's likewise for dollars as well. So it's a really cheap little printer, but it does exceptional results. So I'm going to quickly... Now this is where Amazon have let me down. They should have had the right screws in it, so please excuse the poor quality screws that are in it. But it all just comes apart as sections. Perhaps I shouldn't have screwed it in so tightly, do you reckon? We're thinking. There we go. So there is the top layer. I'll do the back layer first, or second. Here you go. The back layer comes straight off. You can see the quality of the print is really nice. And inside is a 1000 milliamp hour LiPo battery, tucked away nice and neat and safe. I've still not done the review for this board, but now I think I'm well armed to do the review. Now I know exactly how it works and how it fits into cases. So, good fun. I'm going to write up a how-to on this to show you the design process. But while I've got this overhead camera in shot here, you can see, not my random prints, but some other things are on my desk. And I think something happened last week, something Pico related with Wi-Fi perhaps. And 3 new buttons dropped in the letterbox last week. Enviro Indoor, Enviro Weather, and Automation 2040. So Automation 2040 at the top, you can see it's got Pico W. This is industrial automation board. It's about £58 in the UK. So probably about $50 to $55, something like that. Industrial automation controller. So it's got Wi-Fi. You've got some heavy duty outputs and relays on there. So you can control heavy loads with this. I'm not talking mains voltage, but I'm talking heavier than 3 volts for a Raspberry Pi Pico. So you can have a lot of fun with this board to integrate it into your home automation setup if you wish. The other one we've got is the Enviro Weather. So this is a weather station. And I'm fascinated by those. I built one years ago using an old Raspberry Pi Zero, it was at the time. So that's indoor. Sorry, that's the right one. They look similar. I'm doing it overhead like this. And these plug in with something. It's RJ11 connections to weather station components like an anemometer and the rain gauge, that sort of thing. And you can measure wind speeds, rain, and all that sort of stuff, and temperatures, and send the data via Raspberry Pi Pico W to your home setups. It could be MQTT, it could be something else. And the final one is an indoor sensor. So this has got a temperature sensor, humidity sensor, what's it called? Volatile organic compounds. So like sulfur compounds and also air quality sensors, that sort of thing. And that's retailing for about, when it comes out, it'll be about £36, so about $25 to $30. That'll be when it comes out. But these are all 0W boards, and the Pico W board, saying 0W now, aren't I? Very interesting. I can't wait to have a play with them.
Wow, that is awesome. I can't wait to see the tutorial for how you made the case, because it looks so complicated to be able to get all those grooves in at exactly the right size.
I can give you a sneak peek on how I did that right now. Beware the crashing noise of plastic, everyone. There's nothing intelligent about this. It is a case of lots of iterations. A fail mentality with this one. I got it wrong so many times. So the first one, this is it here. This is the one I actually wore to the conference. It was Liverpool Make Fest. We had some guests on the other week to talk about it. Caroline and Dan. Let's get it in shot. There you go. You can see there's none of the grooves anywhere. And the USB-C cutout is massive. It's also not massive enough. I had to file it down at 11:30 the night before the conference when I was setting off at 7 the next morning. That was great fun with 11 men sat on the living room sofa doing that. The next one, I need to remember which one that is now. I think it's this one. No, it's this one. There we go. That one there was better. It had a lip here, so it's cut out for the components. But the problem was there was a component in the top corner here that was just getting in the way. So I made the final version. The final version for now, I should say. And just cut out a bit more of the plastic there. You can just see. So there's a bit more space. I also cut a little bit more out on the bottom. Just give it a better fit. So there's nothing smart about it. In fact, the first one I did failed completely, but it was fantastic, the fail, because it showed me that it actually fit. So this took about 15 minutes to print, and it went completely wrong. It warped on one end. But it enabled me to put it on the Tufty and see that it would actually fit with a little bit of snapping.
Was that using PLA?
Yeah. $20 Amazon PLA Overture Silk Green it was.
I use a lot of Overture there. Yeah, it's remarkably good quality for the price.
It is. And this is the colour the wife picked. She really liked green, and I have to say, I'm
It
very
looks
much
good.
in love with this. It's nice. I've ordered some red as well. It's called some red silk. That'll be here tomorrow, so expect red things to be printed.
Tom's Hardware Red.
It looks great. And if you ever want to try to hook it up to a behind the neck holder, let me know. I can hook you up.
Thank you very much.
Can I just break in really quickly? Because you said about iteration and failure, especially with 3D printed things. I just want to say I have, this is a very small part of my experiments with behind the neck battery holders, and they extend to here. I've been doing them for a long time. So it took, I'm impressed. Yes, trial and error is there's really no way to replace it. I think you just have to figure out how it works, and the only way to do it is to try it. I don't know how else you do.
Yep. Iteration is the best lesson you'll ever get. You'll see what goes wrong. You'll learn from the mistakes. It's brilliant.
Yep.
Yeah, no doubt. It also, I think it calls attention to, if you're going to do that and fail, should you turn down the print quality in some way so that you can fail faster? Yeah.
There's a lot to be said for designing or trying components before you print the whole piece. I'm always but you're just tempted to say, what if I print the whole thing? Maybe this time it will work. And
just reduce the infill.
Yeah.
Right. I mean, if you're just trying to see if
it
fit, if you're just trying to fit test it, right? Maybe you do that. Or I'm still like really eager to see what happens with this new Anchor 3D printer that's coming out in the fall. They haven't sent us one yet, but I know some folks have tested, and it claims to be like 3 times, 4 times, 5 times faster than a regular printer, but
that's awesome.
But much faster if you do it at low quality. So for something like that, you just want to see if it fits, and if you could print it faster, I mean, you would, right? I mean, I guess this is why people need to have a lot of printers, right? How many 3D printers do you have to have?
Wow. All right, I'm behind. This is good. I'm behind, clearly.
How many do you have?
I have just the one. I took a couple year break from 3D printing. I basically, mine broke, and then I got my laser cutter, and that was such a neat, exciting toy. I have 2 laser cutters though, so that.
Oh, which ones?
I bought a cheap Chinese. It's a clone. I couldn't even tell you who the actual manufacturer is. It's a clone of, and the name I'm going to forget. Bought it secondhand from a laser cutting company that was getting rid of it. Didn't realize till I went to go pick it up that it was 700 pounds. So that's a story. That's a story in and of itself. But it's in my garage. It still works great. I've learned to change the laser tube, and then later on I did some work. I've Blitz City DIY. Yeah, it's nice to have a laser cutter, because that is your speed right there. That is your fast prototyping. You just don't have the 3D capability. And then I managed to get a short-term job doing a little bit of design work for Glowforge, and part of the compensation was a laser cutter. And that's actually sitting here right under my feet right now in my office. So
nice. I'm envious.
Yeah, thanks.
The only one I had was a K40 laser cutter, which are the really cheap ones. They're a little bit dangerous. I did get an electric shock from one once, but that's another story. They're decent, but they'll only do about 2 or 3 mil ply. Nothing too special.
Yeah.
You can usually make it with a few passes, but it is nice. The power is nice, and I do dream. I have the downstairs one is 60 watts, and every once in a while I keep checking the prices on 100-watt laser cutters and say, just wait.
That's very cool. And Ash, I know you were working on something.
I just wanted to go over, having Debra on this week is a great time to segue into this, because you were talking earlier about how to get kids started on projects, and whether you're a kid or you're experienced with technology in general, and you just want to know how to get into the pie. I thought it would be worth taking the time to go over must-have tools and accessories and applications that new makers need to get into all of this, because getting started can be somewhat intimidating, but it really doesn't have to be. And so I wanted to list out a few things that you can get off the ground with the basics of building, so that you can use these tools to develop more complex projects gradually. You don't have to jump in head first unless you want to. Sometimes that's how we all learn. Not how we all learn. Sometimes that's how we learn. But you don't necessarily need all of these things. but what I'm going to show you should give a better idea of what kind of components that you could keep on hand to really get going. So first off, hardware-wise, if you want to get into the Raspberry Pi, you need a Raspberry Pi. I don't care what kind of Pi you have. You could have a Pi Zero. You could have a Pico. I usually have like 1 million Picos on hand. Where's my Pico? This one's still in the package. You could have a Pico. You could have a Pi 4 or a 3B Plus. Whatever. Get a Pi. Whatever seems interesting to you. As long as you can afford it, because I know they're all hard to get a hold of right now. But the biggest benefit of using a Pi, any Pi, is the GPIO. And that's because these little pins let you connect all sorts of fun things to it. So if you want to prototype a project on the Pi, it helps to have a breadboard. I'm going to switch my camera over really quick because I had a few examples pulled up on my browser. So get your Pi and then get a breadboard. It looks like this. That way you don't have to solder everything together, because if you solder it together, it's kind of stuck, right? But if you get a breadboard, then you can make temporary connections, do a little testing, go through all the prototyping like we were talking about earlier with 3D printing. If it doesn't work, unplug it, plug something else back in, keep going until it works. And to go along with a breadboard, you're going to need some jumper wires. Oh, come on, computer. There we go. You're going to need some jumper wires. And there's 3 different varieties. You've got male to male, male to female, female to female. Get them all, because you don't know what you need until you're in the middle of a project and then you realize, oh no, I don't have that. It would be great to have that on hand. So go ahead and get all 3 varieties. They're just excellent to keep within reach. So for most beginners, young and old, I highly recommend using simple add-ons at first. And by simple add-ons, I mean, get a button, get an LED, something really easy that's just on and off, 1 and 0. And if you want to step things up a little bit and get a little more complex, you want to start looking at things like sensors, ultrasonic sensors, what I've got here in my hands, or a servo motor, because that will involve not just turning something on and off, but reading data and interpreting that data and using it to maybe trigger another event. So hardware, start easy, build up, keep these on hand. You will need a box for all of your nonsense. I saw Debra pull out her box of stuff. You will need boxes on hand to sort all of your microelectronics, because it's gonna get a little bit crazy, and that's okay. That's part of the fun. So beyond hardware, there's also software. And if you're wondering where to even begin with software, I would say, I don't know. I think everyone likes to start with Python, but if you're a very young maker, I think it helps to use something simple like Scratch. I thought I had a Scratch example brought up in my browser, but I don't. I have more buttons and LEDs. Here's Scratch. There we go. And the reason I recommend Scratch for really young developers is because it's very visual. It's got a drag and drop system that you can use to put things together. But I think Avram would agree, as soon as possible, get your kids experimenting with text-based code. As soon as they're able to understand Python or MicroPython, if you're using small accessories and making LED wearables, right? Get them to use a word-based programming language, because it's going to be much more applicable, not just in Pi projects, but it's just a good skill to have outside of microelectronics. You can use that in your career. And I think it's useful to get away from the drag and drop as soon as possible.
Yeah, I mean, that's been my beef with a lot of so-called STEM toys, is that they're designed for older kids, but they assume that you're going to need to use a block-based language. And some of them don't use Scratch. They use proprietary block-based languages, which is a real no-no as far as I'm concerned. I think any STEM kit that you get for a kid, if it supports a block-based language, should also support a code-based language so that they can graduate up to that. I really, I think it's good. We have Tim in our chat saying that his 5-year-old daughter loves Scratch.
And that's a good target demographic for Scratch.
And that's good, because at 5, most kids can't read very well. So of course, written code is not accessible. But although some of these Scratch things require you to read too, so then you might want Scratch Junior, which is, I think, all icons, or one of my favorite for like pre-literate kids kits is the Lego Boost kits, because the UI for that is completely languageless. So I was having my son program with that when he was, I think, 5. He was programming that, and that was and that was good because he didn't need to read at all. But once you get up to being literate, like first, second grade, I try to switch them to actual code as fast as possible, because that's what's really going to help them. And I feel like you have a lot more. I don't know. I just hate the drag. A lot of things, especially if you're doing on a tablet, I hate the drag and drop, because you end up dropping stuff onto the wrong thing. Is the sensitivity is wrong. I hate personally. I hate dealing with the block languages.
It's a tough transition to make. I know I've been teaching code clubs for a while now, and we start with the microbit drag and drop, but I've had a group of kids with me now for almost 3 years, and we're coding in Python, and the transition it's actually really it's such a powerful language, and with the built-in modules are a little bit the equivalent of the of programming hardware, that you're making things happen right away, really interesting things. There was an intermediate, and I'm blanking on the name, maybe somebody can drop it in the chat. There's Python code blocks written by, and he's a young developer, and it's a really wonderful website that was a very good transition, because you're actually coding real Python, although you're dragging and dropping the blocks, but you can see the Python.
I think we saw
Edgy blocks.
Edgy blocks, that's it. Thank you.
Yeah.
Yes. Those were a really good intermediate tool for my students, I found. Yes, that's them. I recommend
what do you think about Node-RED? Because I've seen you use that before, and it's a lot more visual than just opening up, text-based language.
Yeah, Node-RED's event-driven programming. It's a web programming language. It's exceptionally powerful. You can do pretty much anything you want with it. I think of it as Scratch on steroids. In that it's just dragging blocks together, but you've got the coding element as well. It's based on Node, which is pretty much JavaScript underneath the hood. So you can write your own functions, you can write your own code to work with it to do different tasks. So a famous example in the UK is Professor Lucy Rogers has a team called Black Gang Chine, who go to a theme park on the Isle of Wight, and they hack robotic dinosaurs. And I'm not talking little ones like this. We're talking scale replicas of dinosaurs in a park. And they're all controlled via Node-RED. And they all react to each other. So when a Triceratops roars, the T-Rex will move. And they're all talking to each other using Node-RED. It's fantastic. If you get a chance, have a go with Node-RED. It's really good fun.
I second that. I want to say that because they have blocks for things like Twitter logins and sentiment analysis and all these just built right in. It feels like cheating, but it's wonderful.
What about hardware-wise? Do you guys think I missed anything? We've got your breadboards, your jumper wires, buttons, and LEDs, of course. What else do you think beginner makers could have on hand?
Oh my
Resistors.
Goodness.
Resistors. Ooh, that's a good one.
Resistors. Touch sensors are fun, but I mean,
batteries.
Capacitive touch sensors, and an alligator clips, and you can, that way you can build things and, put pieces of tinfoil. I like having the kids build robots, and just with an alligator clip, so you can make a part touch sensitive over here, far away from your controller, things like that.
That's so interactive. That's going to help make it fun too.
I suggest, especially if you're working with a microcontroller, I suggest having a USB port you can easily turn on and off. So
that's a good idea.
So, I mean, granted, there's probably cheaper alternatives to this, but here I have like a USB hub where all of the ports can have buttons to turn on and off. And if you were just plugging in one, I think you could certainly get a cord with an on-off switch. I know there's some that are made for powering a Pi or whatever, because sometimes you've got to reboot that really quickly, and it's annoying to have to take something like micro USB and pull it out in and out all the time.
Andy in the comments, that's a really good point. He says, if you're going to get a Raspberry Pi, it can help to have an external screen to work with. Yes, for sure. If you don't want to switch between your main computer and back to something else, get a small screen or a second monitor.
Then you can get folding HDMI screens now from Amazon for about $80 to $100. I mean, they're not big, not good resolution, but they're enough for a kid to get started.
Yep.
It's going to get a lot of use.
Yeah, I have a Raspberry Pi 400 exactly with a portable screen exactly like that. And it's exactly what I take for if I'm going to do hands-on demos and things like that. Because because you have the simple GPIO, it's easy to set up. And it's literally a 5-volt. It just needs a 5-volt power supply to set up the screen, and a USB, and just a small HDMI cable helps. And I was also going to recommend, these are fun with Raspberry Pi, the little joysticks, the mini joysticks. We've had fun hooking those up to things too. They're pretty.
That is really cool, particularly if you're working with CircuitPython, and then you could actually attach it to a regular PC and use it.
I recommend also not just a keyboard, but this one has like a mouse built into it, so you only have to tie up one USB port because it helps to have the ability to log in.
Yeah. If you're actually, I have one of those around, exactly the board you have, Les, except I lost the dongle for it, so it's.
Oh no!
So I guess my 3-year-old just runs around playing with it. I let her just play with it because it doesn't work anymore. But for me, because no dongle. But that's okay, because what I would recommend in the keyboard situation is if you have a keyboard and mouse that are Bluetooth on your regular PC, and you've got a regular PC here, then you get ones that you can switch. So, granted, this is not cheap for kids or whatever, but if you have something like, I love my my Logitech MX Master mouse that can switch device up to 3 devices, and my keyboard here, which can switch to up to 5 devices, so I can just hit a key on the keyboard and be controlling the Pi, and a button on the mouse and be controlling the Pi if I want to just use the main ones that I have. Anyway, I want to thank Debra for giving us so much of her time and for doing such amazing work online and being such an inspiration to everyone. Thank you so much for joining us. We are here every Tuesday at 2:30 p.m. Eastern, 7:30 p.m. UK time, and we look forward to seeing you all next week. Bye, everyone.
Hi, thank you.